Students, let us look at question number 41 now. M is a metal that belongs to period number 4 and its ground state spin only magnetic moment is 4.9 Bohr magneton. It means that the number of electrons which are unpaired is equal to 4. We have to comment on the maximum number of electrons with m equal to 0 in one atom of the metal M. So if we try and fill up the electrons in the orbitals starting from the 1s, we have 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. So we have now started in the fourth period. So it can contain d electrons. So our first guess would be that we could probably have all the 4 electrons of d unpaired. But students, this is the configuration of chromium and we know that it does not exist as such. We have 4s1, 3d5. The excitation of s electron to d electron takes place because of the stabilization provided by the half-filled orbital configuration. So our next guess would be 4s2, 3d6. Now if you look at the d6 configuration, this has a total of 4 unpaired electrons. So the configuration which we are looking for is this configuration, which has the valence configuration of 4s2, 3d6. Now if we look at the number of orbitals which have m value equal to 0 as mentioned to us in the question, we know that all the s electrons have m value equal to 0. So we have all the s electrons. So these are 8 in numbers. If we talk about the p electrons, we know that only one of the 3 orbitals present in the p subshell has an m value equal to 0. So we have 2 electrons in the 2p6 and we have 2 electrons in the 3p6 as well. So we'll have a total of 4 electrons in the p subshell which have m value equal to 0. And now if we talk about the d orbitals, we know that there is only one single orbital present in the d subshell which has an m value equal to 0. So the examiner is interested in the maximum number of electrons. So students, we can have the paired of electrons of d orbital present in the orbital having m value equal to 0 itself. So we'll have another 2 electrons from the 3d. So if we talk about the total number of electrons having m value equal to 0, we have a total of 14 electrons which follow the above condition. So students, the answer which we are looking for in this question is option 3. Let us look at question number 42 now. Question number 42, it says, a microscope is able to locate an electron in an atom within a distance of 1 angstrom. What is the minimum uncertainty approximately involved in the measurement of velocity in meter per second? So students, we have to use the Heisenberg's uncertainty principle in this case. So we have delta x, which is the uncertainty in position, into delta p, which is the uncertainty in momentum, greater than or equal to h upon 4 pi. So students, if we talk about the values given to us, it is said that the delta x value is equal to 1 angstrom. So we can put it equal to 10 to the power minus 10 as the examiner seems to be interested in the SI units. Now, if we talk about the delta p term, we can have m delta v greater than or equal to h upon 4 pi. The value of m is equal to 9.1 into 10 to the power minus 31 kilograms for an electron. The value of h is 6.62 into 10 to the power minus 34, which is also again in SI units. So if we put the values of this species given to us, we have delta v greater than or equal to 6.62 into 10 to the power minus 34 upon 4 into the value of pi is 22 over 7 into 9.1 into 10 to the power minus 31, and there will be a 10 to the power minus 10 factor which we can write it in the numerator as 10 to the power plus 10. Okay. If we solve this expression, we have the value of delta v equal to 5.79 into 10 to the power plus 5. So students, the answer which we are looking for in this question is option 3. Let us look at the next question. Question number 43. Consider the following statements. So S1, it says the size of scandium-21 is highest in the 3D series. Students, this statement is correct. Among the 3D elements, scandium has the greatest size. If you look at S2 now, size of zinc is more than cobalt. This statement is also correct, students. The size, it keeps on decreasing up to nickel and then it slightly increases for copper and zinc. There is an exception of Mn in between. So we have scandium over here and we have zinc over here. So the second statement is also correct. If you look at the third statement, size of zinc 30 is highest in the 3D series. This statement is incorrect, students. In the 3D series, the highest size belongs to scandium and not zinc. Let's look at statement 4 now. The size of scandium is higher than nickel. Students, this statement is also correct. So, the examiner seems to be interested in the options which contain only incorrect statements. So, students, out of the given statements, only S3 is incorrect and we have to mark option 3 as the correct answer to our question. Let us look at the next question. Question number 44. Consider the graph 1 for first group elements which are lithium, sodium, potassium, rubidium and cesium. So in the graph 1 we have the atomic radius varying with the atomic number. Students, we know that the atomic radius for group 1 elements has a smooth increment down the group. So A is Li, B is Na, C is K, D is Rb and E is cesium. If you look at the graph 2 now, the graph 2 represents the variation of ionization energy with the atomic number. So the examiner has told us that the position of alkali metals Li to Cs in graph 2 is represented as 1, 2, 3, 4 and 5. Examiner seems to be interested in the location of element D in the graph 2. So if you look at graph 1, the element D is rubidium. And if we talk about the variation of the ionization energy with atomic number, students, this periodic property also has a smooth decrement down the group with the atomic number for the alkali metals. So students, the element represented by 1 will be Li, the 2 will be Na, 3 will be K, 4 will be Rb and 5 will be Cs. So if we talk about the correct matching of D from graph 1 in the graph 2, we can see that the correct matching should be equal to 4. So the element rubidium is represented by D in graph 1 and represented by the number 4 in graph 2. So students, we have to mark option 3 as the correct answer to question number 44. Looking at question number 45 now, consider the information about the elements A, B and C. So element A is present in group 15 and period 4. Students, the element A is arsenic. Let us look at the next statement now. Element B. It is present in the same period as that of element A, but the group number of B is 12. Students, the element which is present in period 4 and group 12 is zinc. Let's look at the element C now. It is present in group 11 and period 6. Students, the element C is gold, represented by Au. So we have to select the correct statements about these elements. Element A and B belong to the P block, but element C is a transition element. Students, the element B is zinc and it is not a P block element. So statement 1 is incorrect. If we look at statement 2 now, number of unpaired electrons varies as A greater than C greater than B. So if we talk about arsenic, arsenic has a valence orbital configuration of 4s2 4p3. If we talk about zinc, zinc has a valence orbital configuration of 4s2 3d10. And if we talk about gold, gold has a valence orbital configuration of 6s1 5d10. So if we talk about the number of unpaired electrons represented by letter N, we have the value of N equal to 3 for arsenic, the value of N for zinc shall be equal to 0, and the value of N for gold shall be equal to 1, which is the 6s electron. So students, if we talk about the number of unpaired electrons, we have A is greater than C is greater than B. So statement B is correct. If you look at the third option now, element C is liquid at room temperature. Students, this statement is incorrect. The element C is gold and gold is not a liquid at room temperature. If you talk about statement 4 now, all three elements are non-metals. Students, this statement is incorrect. We have gold, we have zinc, those are metals. Students, the answer which we are looking for in this question is option 2. Let us look at the next question now.